All right, so continuing on for number 14, we are factoring x squared plus 19x plus 90. So we're going to go ahead and start. It's already in standard form, and there's not any greatest common factor I can pull out. So I'm going to start with two numbers that multiply to AC, which is 90, and B, which is 19. And those two numbers are 10 and 9. So then I rewrite this, x squared plus 10x plus 9x plus 90. And then I group this side and group this side. And on this side, I can just pull out an x, and I'm left with x plus 10. And on this side, I can pull out a 9, and I'm left with x plus 10. Then I pull out whatever's in parentheses, which is just the x plus 10, so these are gone. And I'm left with an x and a positive 9, so I have x plus 9. So then I come over here, and the answer is B, which has its nice star by it, so I know it's the answer, x plus 9 times x plus 10. And then we'll go ahead and switch to the next page and start on 15 and 16. So on number 15, people sometimes struggled with this, but it's actually an easier way to factor. So if we start by factoring out the greatest common factor, I can pull out an n, and then I'm left with n plus 4. And this is already factored. I can just set each of these equal to 0. So I have n equals 0, and n plus 4 equals 0. This one's already solved for n. This one I just minus a 4 from each side, and I have n equals a negative 4. So my answers are 0 and negative 4, which is C. And then 16 is the same idea. I can pull a p out, so I have p times p minus 5, and I set the p equal to 0, and I set the p minus 5 equal to 0, add a 5 to both sides, and p equals 5. So I have 0 and 5, which is A. 17 and 18 is the same factoring steps that we went through when we did 13 and 14. So it's already in standard form, and there's no greatest common factor I can pull out of all three of these. So I'll start with my two numbers that multiply to AC, and A is 5, C is 14. 5 times 14 is 70, and B is negative 17. So I need two numbers that multiply to 70 and add to 17. So 7 times 10 is 70, but since this is a negative 17, I need a negative 10 and a negative 7 so that they add to negative 17 but still multiply to 70. So I can rewrite this 5x squared minus 10x minus 7x plus 14. And then I group each side. This side I can take out a 5 and an x, so I have 5x, and I'm left with x minus 2. This side I can take out a negative 7, which leaves me with x, and then 14 divided by a negative 7 is a negative 2. So then this factors to x minus 2, and then I get rid of both of these, and 5x minus 7. So then I can just set each of these equal to 0 and solve for x. So I have x minus 2 equals 0, and if I add a 2 to both sides, x equals 2. And then I have 5x minus 7 equals 0. If I add a 7 to both sides, 5x equals 7, and then divide both sides by 5, and x equals 7 over 5. So I have x equals 2 and 7 over 5, which is D. And then 18, same idea, so I need my AC, which is 7 times negative 6, so a negative 42, and B is 1. So two numbers that multiply to negative 42 and add to 1 are negative 6 and 7. So then I rewrite 7x squared minus 6x plus 7x minus 6. Group this side and group this side. So on this one, all I can pull out is an x, and then I'm left with 7x minus 6. And then this one doesn't have any greatest common factors, so the only thing I can take out is a 1, and I'm still left with 7x minus 6. But fortunately, my parentheses match, so this factors to 7x minus 6, and then to x plus 1. So I just need to set each of these equal to 0 and solve. So I have 7x minus 6 equals 0, and x plus 1 equals 0. So this one I just minus a 1 from each side, and x is negative 1. This one I add a 6 to each side, so I have 7x equals 6, and then divide both sides by 7, and x equals 6 over 7. So my answer is 6 over 7 and a negative 1, which is A. 19 and 20 use some somewhat fancy notation, but the process is actually very simple. So it's asking me to find k of 2, and it gives me what k of x is equal to, x cubed plus 3x squared. So wherever there's an x, I'm going to plug in a 2. So I have 2 cubed plus 3 times 2 squared. So 2 cubed is 8, and then 2 squared is 4, because I have to do exponents first, according to order of operations. And then I have 8 plus 3 times 4 is 12, and 8 plus 12 is equal to 20. So 19 is B. And then the same idea on number 20, I plug a negative 3 in for x, so I have 2 times a negative 3 minus 4. 2 times a negative 3 is a negative 6 minus 4, which is a negative 10. And then on to 21 and 22. So this was just from our very last unit, unit 7, and it wants us to solve by taking square roots. So since this already has what's being squared by itself, I can just take the square root of both sides, and the square root and squared cancel, and v equals the square root of 25, which can either be a positive 5 or a negative 5, which is C. This one is the same idea, except my v squared's not by itself yet, so I need to get it by itself before I can take the square root of both sides. So I'll minus a 10 from each side, so these cancel, and I have v squared equals 2 minus 10, which is a negative 8. And then I take the square root of this side, take the square root of this side, and I have v equals plus or minus the square root of negative 8. So because this is a negative here, I know I'm going to have an I, and then I need to figure out what the square root of 8 is. So if I break this down, 8 is 4 times 2, and then 4 is 2 times 2. So I have plus or minus I, and then the square root of 2 times 2 times 2. So because I have two 2's, I can pull out a 2. So now I have plus or minus 2i, and all that's left under the radical is a 2. So that is right here. So the positive 2i squared of 2 and the negative 2i squared of 2. So now I'm going to tell you on your test how you could get some bonus points. So if on the second page of your test, at the bottom, you write, Mrs. Brandley is my favorite teacher, I'll give you 2 bonus points on your test. So make sure it's on the bottom of the second page of the test we take Monday. Mrs. Brandley is my favorite teacher, which I know must be true for all of you, so you're not even lying. Okay, so now we're going to go ahead and finish this review. So I have the quadratic formula. I'm going to go ahead and write it up here for us to remember. So now I need to figure out what my A, B, and C are in this equation. So in order to do that, I'm going to add a 10n over. So I have 12n squared, and then plus 10n plus 9. So now my A is 12, my B is 10, and my C is 9. So I can go ahead and just plug those numbers into here. So I have a negative b, which is a negative 10, plus or minus the square root b squared, so 10 squared, minus 4 times a, which is 12, and c, which is 9. And that's all over 2 times a, which is 2 times 12. So now I've got to simplify. So I have negative 10 plus or minus the square root. 10 squared is 100. And then 4 times 12 times 9. I'm going to cheat and use a calculator. So 4 times 12 is 48. And then 48 times 9 is 432. So I have 100 minus 432 all over 24. So this simplifies to negative 10 plus or minus the square root of 332 all over 24. So now I've got this 330, oh, and this is a negative 332. So I've got this 332 that needs simplified. So I'm going to do a side calculation over here and simplify the square root of 32. So because that's a negative, I can bring an I out front. So I have I and then the square root of 332. So I'm going to go ahead and break this down. So let's see, what times 2 is 332? If I do 332 divided by 2, that's 166. And then 166 breaks down into 2 and 83. And 83, if I try that a few times, 83 divided by 2 doesn't work. 83 by 3 doesn't work. And if you keep trying, you'll notice that 83 is actually a prime number, even though it's big. So now I have I and the square root of 2 times 83. And I can pull out a 2, so I have 2i times the square root of 83. So that's what this simplifies to. So now I have negative 10 plus or minus 2i, square root of 83, over 24. So the only thing I have left is to see what goes into each of these three terms. And from what I can see, it's a 2. So negative 10 divided by 2 is a negative 5. And then this 2 divided by 2 is just 1. So I'm just left with I root 83. And 24 divided by 2 is 12. So if I come over here, that answer is B. Okay, we're down to our last two problems for the second part of your review, 24 and 25, and we're finding the discriminant. Notice on your review, this 2 is missing, so make sure you add it in if you haven't already. So b squared minus 4ac, this is a, b, and c. So I have a negative 4 squared minus 4 times 5 times 9, which is 16 minus 4 times 5 times 9, which is 180. 16 minus 180 is a negative 164. So it's got to be one of these first two solutions. And because this is a negative number, it has two complex or imaginary solutions. You can say it either way, and in this case it says imaginary. So a negative discriminant gives you two imaginary solutions, a positive gives you two real, and then 0 gives you a repeated solution. So then I do the same idea over here. I have my b's a negative 10 squared minus 4 times a, which is 7, and c, which is 4. Negative 10 squared is 100. 4 times 7 times 4 is 112. So I have 100 minus 112, which is a negative 12. And since this is negative, it's going to have two imaginary solutions, and my answer is B.